Hey folks, Mr. Bucko here with problem number 6 from your Geometry Chapter 6 self-test, where we have this triangle BRT, and we're going to find the value of x, and we have all of these angle measures that are given to us, and we can use how they relate to each other, the relationship to find the value of x. So a couple things that we want to kind of point out here is that I think that it's fairly obvious that 4x plus 3 is this angle here because the arrow's there. This 3x plus 8 is this angle right here because the arrow's pointed there. These two, not very clear exactly which angles they are. So that would be a good clarifying question to ask because it's not obvious to me. But it turns out that this 4x plus 50 degrees is this angle right here, which appears to be a 90-degree angle, but we can't assume that. And then this 5x plus 40 degrees is this angle right here, this BFT, and then the 4x plus 50 is this BFR. So that's what those two angle measures are. It's not this angle R, this angle T, which is not very clear. And if you assume that this is angle R and angle T, then the work that we would do is completely different. But this right here is this angle. This right here is this angle here. So based on that fact, we know that this 4x plus 50 and this 5x plus 40, they're a linear pair. This line is a straight line. These two are adjacent angles. They have to add up to 180. So I'm going to take those two values, 4x plus 50 right here. I'm going to add it to 5x plus 40, and that has to equal 180 degrees because they're a linear pair. Combine like terms, and we get 9x plus 90 equals 180. Subtract 90 on both sides. Doing our basic algebra, and then we'll find out that the value of x is 10. So the value of x is 10 based on the fact that we know that these are a linear pair. Add up to 180, and then just doing our basic algebra gives us x is 10. The next question asks, is it true that BR is equal to BT? So is it true that this length is the same as this length? And then we're going to justify our answer. Well, if this is the same as this, if BR is the same as BT, then that means that this is an isosceles triangle. So essentially what we're trying to show is this an isosceles triangle or is it not? Well, if this is an isosceles triangle, then that means that this angle BRT would have to be equal to BTR. So if this is an isosceles triangle, this angle right here would have to be the same as this. So if we find those two angle measures, and if they're the same, then this is an isosceles triangle, and those will be the same. If they're not the same, then this is not an isosceles triangle, and they're not the same. So what we can do here is we're going to find angle BRT. So we're going to find this angle right here by using this angle measure that's given, and this angle measure that's given, because this is this angle here, and the fact that we know that x is 10. So this work that I have is 180 because this angle, and this angle have to add up to 180 because this is clearly a triangle. And then we're going to subtract 90. Where does the 90 come from? The 90 is this angle right here because x is 10. So this is a 90-degree angle, it turns out, because if x is 10, 4 times 10 is 40, plus 50 is 90. So this angle is indeed 90. This angle right here is 38, because again, x is 10. So we subtract 180 from the sum of these two angles to get that angle measure. That angle measure has to be 52. BRT, this angle right here, or BRF, is 52 degrees. Let's find BTR or BTF using the exact same method. We know that this angle here is 4x plus 3, so that means that this has to be 43 degrees. This angle here is also 90 because x is 10. 5 times 10 is 50. 40 is 90. Therefore, this remaining angle, BTR, has to be 47 degrees because they all have to add up to 180. So what's happened here is this angle's 52, this angle's 47. These two angles are not the same. Therefore, this is not an isosceles triangle. And if this is not an isosceles triangle, BR is not the same as BT.